because in 5.4 we're looking at sum indifference formulas. The sum of two angles and the difference of two angles. So using the sum indifference formulas to evaluate trigonometric functions, verify identities, and solve trigonometric equations. Now the sum indifference formula, so I gave you the reference sheet already, so they have them there. They're down at the bottom of the first page. So sine of u plus v is equal to sine of u times cosine of v plus cosine of u times sine of v. So essentially the two angles switch. And then we have sine of u minus v. We have this formula, cosine of u plus v, cosine of u minus v, and then our tangents. Now, if you notice with sine and cosine, well, the sine of the sum or difference, cosine and sine, are next to each other. Sine, because if we look here and here, sine, cosine, cosine, sine. Sine, cosine, cosine, sine. For cosine, 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 sine, sine. Cosine, cosine, sine, sine. Notice that there. So that's kind of the main difference. And when I look at it and see them and I'm trying to keep them straight, well, sine, the operation in the middle is the same, and we're just switching the angles. Sine of u, sine of v. Welcome. So we look at these here, kind of the way I keep them straight is with sine. They're together, sine and cosine. Going to have sine and cosine, we just switch it. And the addition, the sign in the middle is the same as what we're doing. So when I'm adding two angles together for sine, well, it's going to be addition. Subtracting, subtracting. Cosine's kind of the opposite. When we're adding, we're subtracting. When we're subtracting, we are adding, and sine and cosine go together. But you don't have to memorize these. You will have this sheet on the test. You can use it. And we have these here. And the reason we have this is kind of for like sine of pi over 12. Because if we're sticking purely to the unit circle, pi over 12 is not on the unit circle. It's not one of the angles that would be a part of the unit circle. But what I can do, sine of is 1/3 minus 1/4. Well, I can't actually subtract this. I'd have to change it to 12, so this would be 4/12 minus 3/12 gives us 1/12. Or if we dealt with pi, it would be pi over 12. So pi over 12 is the same . So with addition, subtraction, if we didn't have these angles between them, like pi over 12 isn't on the unit circle, and we had to stick purely to the unit circle, well, pi over 3 minus pi over 4 gives us pi over 12. So sine of pi over the 12 is the same as sine of pi over 3 minus pi over 4.
So the sine and cosine of pi over 3.
So sine of pi over 3, cosine of pi over 4 minus
Sine of pi over 4. Cosine of pi over 3. Okay.
Because u and v, it's just sticking to that formula. Because sine of u minus v is sine of u cosine v minus sine of v cosine u. But now we can use the unit circle. The sine of pi over 3 is going to be square root 3 over 2. And cosine of pi over 4 is going to be square root 2 over 2 minus Sine of pi over 4 is square root 2 over 2. And this here would be 1/2. We can multiply these together. So we get 4, because
Oh, because, yeah, okay. That makes sense.
square root of 6 minus the square root of 2 over,
So, wait, wouldn't it be 4?
it's just 4. Because the square roots are only on the
Yeah.
top. Now, if you want to, grab the white calculator, either one really. I'd grab the white one because it does radicals. Take sine of pi over 12 and make sure it's in radians. Yep.
Six squared. It's that.
Give you the exact same thing. So this here helps if we're sticking just to the unit circle, or we had a restricted amount that we had. I can find it using this addition and subtraction. Makes it easier to solve. Now, especially if we are looking at, we're given our set of numbers, our tables, if we actually had to deal with trig tables for certain numbers over 100. So if we were only given 0 to 90, but I wanted to find 92 degrees, well, I could do, or I can do 90 plus 2. Or we can do any combination of those using this sine, cosine, and tangent to find these here. And that's kind of why they're useful. So it's pi over 12 is equal to pi over 3 minus pi over 4. Plugged it in, and we got this here. Now we can do this using the 2-column proof, the same type thing. Now we have this already. Cosine of pi over 2, or 90 minus x, is equal to sine of x. Okay, that's one of our theorems. Yes? Now, cosine of pi over 2 minus x. Well, this here would be cosine of pi over 2 times cosine of x plus sine of pi over 2 sine of x. Because according to our angle sum theorem for cosine, or not subtraction, or difference, because the difference is on the back of the first page for y'all. We get this here. So u is going to be, for alpha, I used alpha and beta. Alpha would be r pi over 2, beta would be x. And we just plug in for alpha and beta. Now, cosine of pi over 2 is going to be what? This cosine of pi over 2 is straight up, so it is.
That, so sine's 1, right?
This whole thing becomes 0. Because pi over 2 is straight up, cosine is in the x coordinate, sine is in the y. And we have this here. Questions on this here so far? Sum and difference, sine of theta. Now, we can also use this for solving some equations like this here. Find all the solutions And really there's supposed to be a bracket here and here, of sine of x plus pi over 4 and sine of x,
Fine.
yes, yep, is equal to -1.
So we're solving for x, right?
Yes. So really, if I can get sine of x by itself, or get x by itself, sine, cosine, whatever it is, then we can solve from there. Well, sine of x plus pi over 4, well, that's the same as sine of x cosine of 4 plus sine of pi over 4 cosine of x. Plus, we're going to do the same thing here. It's going to be sine of x cosine of pi over 4, but this time it's going to be minus sine of pi over 4 cosine of x equals -1. So I just utilize those two signs, the sum and difference formulas for sine, alpha and beta. So, well, alpha and beta, alpha was x, beta is pi over 4. Alpha is x, beta is pi over 4. Questions on this here? Yes. So we're utilizing those sum and difference formulas. We're using each one once. Because this whole thing here is this part.
Yes.
Now there is something that does work out nicely. So, well, here, let's just simplify what we can. I'm going to use a different color than blue. Over here. Let me use red. These four here have a value. Because cosine of pi over 4 is going to be square root 2 over 2. Actually, all four of these are going to be square root 2 over 2. So really what I have here is square root 2 over 2 sine of x plus square root 2 over 2 cosine of x. I so wanted to write sine. Cosine of x plus, now it'd be square root 2 over 2 sine of x minus square root 2 over 2 cosine of x is equal to -1. Well, hey, so when I add these two together, I get square root of 2 sine of x is equal to -1. Yes.
Square root 2 over 2, right?
Yes. I mean, well, almost, but yes. Because sine of x would equal, it would be square root 2 over 2 negative square root 2 over 2. Because it's equal to -1. Questions on this here? Now, let's look back at the top. Find all solutions for this on the interval of 0 to 2 pi. So we have restrictions. So where is sine of x equal to negative square root 2 over 2? Because they're going to be in the third and fourth.
Sine.
7 pi over 4.
And you wouldn't add
because we're on the interval of 0 to 2 pi. Now,
Didn't have that.
then we would do that, but notice something. 2 pi is not included because we have the parenthesis bracket around 0. Because 0 and 2 pi have the same value. Because sine of 0 and sine of 2 pi are both 0. Cosine of 0 is 1. Cosine of 2 pi is 1. We can only have one of those. So we got 7 pi over 4 and 5 pi over 4. Now, if we wanted to, what we could do at this point here, I'm going to erase this. For this problem here, it's not going to be an issue, but we could go back and check it. Sine of 7 pi over 4 plus pi over 4 plus sine of 7 pi over 4 minus pi over 4 plus equal -1. Well, 7 pi over 4 plus pi over 4. So we have 7 of them, and we add another one to it. We'd have 8. 8 over 4 is?
I was thinking the subtraction.
Would be 2 pi.
That would be good. The other one would be 6.
6 pi over 4, which is 3 pi over 2. And sine of 3 pi over 2 is? -1. It's straight down. So it works. Now the other one was 5 pi over 4. Sine of 5 pi over 4 plus pi over 4 plus sine of 5 pi over 4 minus pi over 4 supposed to equal -1. Well, that'd be 6 pi over 4, which is pi over 2. This here would be sine of, it's 5 pi minus pi is 4 pi. 4 over 4 is 1 pi.
And that's good. Good one. Like it did last time.
Yep. And that's it. Questions on this here? So they did it this way. They didn't simplify cosine of pi over 4 because sine, cosine pi over 4, cosine, sine pi over 4. These here. Well, for us, like we noticed, these two here canceled. And we have 2 of that one there. Well, now they did it. Then they used the square root of 2 over 2, which got us to this, which gave us our 2 solutions. And that was it. And if we plugged them back in, we got our answer. Yeah, this one here, there's always a few I want to do with you. Find the exact value of cosine of 75 degrees. Well, if I wanted to, I could plug this into the calculator, and the calculator would actually give this to me. No. But I do know that is 75, and both of those are on the unit circle. 30 and 45 are two of our main, 30, 60, 90. 30, 60, and 45 are the three kind of special angles. So we could use this here to solve it. So it'd be cosine of 45, cosine of 30, minus sine of 45, sine of 30. Square root 2 over 2. Minus square root 2 over 2 and 1/2. Well, I've gotten it down that if cosine of 30 is square root 3 over 2, sine of 30 is going to be 1/2. They go together. Well, here in the denominator, well, 2 times 2 is 4. Square root of 2 times square root of 3 would be, here I'm going to have square root of 2 over square root of 6 minus square root of 2 over 4. And that's it. Questions on this here? I mean, that's it. There's ways that we could possibly combine those radicals, but it's not going to make it any simpler. But that's it. Questions on this here? I mean, also, if you did cosine of 75 degrees, it would actually give you the answer also. Okay. Find the exact value of sine of u plus v given sine of u is equal to 4/5 and 0 is less than u is less than pi over 2. Cosine of v is equal to negative 12/13 and pi over 2 is less than v is less than pi.
So the cosine right?
Yep. So looking at this here, I draw pictures. Well, I draw 2 coordinate planes because u is between 0 and pi over 2. So angle u here is in the first quadrant because that's telling us angle u is between these 2 values, so it's in the first quadrant. V is in the second because pi over 2 and pi. So I use these to kind of figure out where we're at. Now for cosine, opposite over hypotenuse. Opposite over hypotenuse, and the other side would be 3, because it's a 3, 4, 5 right triangle. Cosine is adjacent over hypotenuse. Is 5 squared plus 12 squared. 5 squared is 25, plus 144 is, and the square root of 169 is 13. It's also another Pythagorean triple, because I do know those 2, and then I think it's one other, but it's mostly, I think it's 7, 24, and 25. There's like a handful that I know off the top of my head. But the key for these here is setting these triangles. Because setting up these triangles is going to make these a lot easier to figure out. Because once I get the coordinate and putting them in place, it'll be a little bit easier. Also, it helps with signs. His first quadrant, positive, positive. Second quadrant, well, negative and positive. So it helps me get the signs. Okay. Any questions on this here so far? Okay. Now, sine of u plus v is going to be sine of u cosine of v plus sine of v cosine of u. That's just by definition, the formula, yes? Well, okay, I'm going to have to erase some of this here. Now, we were given those two from the get-go, yes? Was I told what sine of v is? Well, no, sine is opposite over hypotenuse. V, opposite would be? We also weren't given cosine of u, but I can go over here, adjacent over. That's why I drew these. That's why, especially when I do these, I always redraw the triangles because it's helpful to look at them and make sure sines are huge, and this will give me everything I need. Well, 5 times 13 is going to be 65. 4 times negative 12 is negative 48. It's going to be 65. Because again, the hypotenuses are the same on both, 5 and 13, so they would be 15. Negative 48 plus 15, negative 33 over. And that's it. And that's it. So with any of these here, it's really these triangles here make these problems a lot easier because I can set the triangles up. I can find sine, cosine, tangent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent to find those. Okay. Okay. I actually have the book out right here.